This is Goddess of Science Physics, and I'm Mrs. Bolvin. And today we're going to talk about the falling boulder. Now, I know that's going to be like crazy exciting for you, but just hang on. This is part 4 of Newton's third law of motion. So we're talking about action and reaction with different masses. So when a boulder is falling to the ground, the earth is pulled up by the boulder with it just as much force as the boulder is pulled down by the earth. And you're like, well, I don't think that's really true. Newton's third law of motion says that for every action, there's an equal and opposite reaction. So the action force is the earth pulling down on the boulder. The reaction force is the earth being pulled up by the boulder. Whoa. So why is it whenever anything falls, we don't feel the earth moving toward that object? Well, it all has to deal with mass. So the interaction is between the boulder and the earth. The boulder pulls up on the earth with a force equal to what the earth pulls down on the boulder. Okay, that's Newton's third law. The boulder falls to the earth, but the earth also falls to the boulder. But the distance that the earth falls is much less because force is equal to mass times the acceleration. We're not accelerating as much because we have a huge mass of the earth. So, pair of forces between the boulder and the earth are equal, but the masses are not. The boulder is a fraction, a very, very tiny fraction of the mass of the earth. So, because Newton's second law says that acceleration is directly proportional to the net force, it also is inversely proportional to the mass. So while a huge force may cause a big acceleration, if that mass that it's accelerating is actually really, 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 really huge, the acceleration is going to be really small. So because the earth has a huge mass, we don't sense the very, very tiny acceleration that happens when something falls to the earth. Well, thanks for joining me. Have a great day.